We are Ham Radio Perspectives. I am Quinn, K8QS.
And I am Tom, WA9TDD.
In this video, we're talking about coax, more or less everything you need to know about coax, which practically every ham uses, unless they've got a lot of money and they're using some hardline or something. So coax, very important, goes from the rig out to the antenna, but also around in the shack from piece of equipment to piece of equipment. What do we need to know, number one, Tom, about coax?
Okay, number one, you need to know the characteristic impedance of the coax. Now, almost all amateur radio equipment, transceivers, tuners, amplifiers, are designed for a 50 ohm load. And your standard coax, your RG8, RG213, LMR400, RG58, they're all 50 ohm cables. That means that they're set up for 50 ohm impedance. The 75 ohm exception, cable TV coax RG6 is 75 ohm. While it can certainly be used for antennas like a resonant dipole, which is actually naturally near 75 ohms impedance, will cause a baseline standing wave of 1.5 to 1 on a standard 50 ohm radio system.
No big deal.
No big deal if you have an antenna tuner.
Yep.
What's number two, Quinn?
Yeah, number two is line loss. So coax has what we call attenuation. You lose some of your power, and there's some factors involved here. One is how far away to the antenna it is. The longer your coax, the more you're going to lose. Another is the frequencies you're operating on. So the higher the frequency, the more loss you're going to have. And when you get up to UHF, VHF, and higher than that, you want to use really good coax with minimum loss, because that's where you'll start to see the loss. And then you've also got the actual coax itself, its diameter, which greatly affects how much loss you will have. And people debate what you need on this. We would say don't use the real thin stuff, the RG174, because unless it's just for receive, then you could go to RG58, which is a little better and a little bigger around. But the one that I like, Tom, the next one around is RG8X.
Yeah.
So I normally use RG8X. It's kind of a medium size, but it's great all-around cable for HF. And you can easily run that 100 feet, and you're not going to have much loss on HF. And then you can, if you're really going to run a lot of power and you really want to minimize the loss, then you definitely want to go with LMR 400. Yeah. LMR 400. We'll say a little bit more about LMR 400, some of the good, the bad, and the ugly in just a minute. So just take those 3 points about coax into account.
Okay, and number three to consideration is the velocity factor, as abbreviated VF. And the signal travels slower in coax than it does in a vacuum. This is known as a velocity factor, and it affects the apparent length of the antenna. A solid polyethylene core, usually around 0.66 inches. You have a foam dielectric that's usually around 0.8 to 0.85. And this is critical if you're cutting coax to a specific electrical length for phasing lines or impedance transformers, or stubs if you cut a quarter wave stub without accounting for the velocity factor, because it'll physically make your cable either too long or too short and fail to work at that target frequency.
Right. Number four is the power handling, which I briefly mentioned. So coax is designed to hold a certain amount of power. We'll say power in watts, if we can put it that way. So, but let's put it this way. Coax has voltage and thermal limits, how much voltage you're going to be putting through there related to the power level you're running, and then also thermal limits in terms of how much heat you're going to generate with the power that you're running in the coax. And with real thin coax, putting too much power in there, one of the things that'll happen is you will start to melt the coax, not just get loss with it from lowering the power, but you'll actually start to melt it. We call it dielectrical melt, or it may even arc from the jacket into the center to the jacket, or at the spot where you're connecting to your antenna. It's pretty crazy. But the most common thing to consider with respect to power handling is how much power you're going to be running, and choose that coax according to what you want to run. And related to that is which mode you're going to use. So if it's 100% signal mode, like digital or radio teletype or AM or FM, then you're going to be right at the max maybe with the coax that you choose. If it says it's fine up to 200 watts and you're going to run 200 watts, key down, so to speak, I wouldn't do it. Get a type of coax that you can run more than that with it. But when I look at something like RG8X that I use on sideband primarily, sideband's peaking, as you talk up and down, I'm never going to reach the maximum power to put through that thing. I'm never going to have trouble with it. If I went out and got an amplifier, 1500 watt amp, then I might consider what to do, especially if I've got it key down.
Okay. And number 5, the consideration is for the shielding for either causing interference or accepting interference from, radio propagation or electrical noise. The shield part, the braided or foil elevator conductor, is what keeps your signal inside and the noise outside. Now, you've got coax that has a braid only. That's good for HF. It's very flexible. You've got the kind of coax that has a foil and a braid. That's even better for VHF, UHF, and prevents signal leakage and interference. Quinn used cable company 75 ohm coax with double shield.
Yeah. It was a bear. It was a bear to work with in terms of getting a connector on there,
right?
But good coax.
And that's what I suggested, using F connectors on 75 ohm coax and crimping them on. Much better than trying to get into a PL259 and soldering aluminum to the connector. Okay.
Oh, terrible.
The other consideration with the coax is, common mode current. Sometimes the RF leaks into the outside of the shield, and that's fixed by using a 1-to-1 balun or a choke, ferrite beads at the antenna feed point.
Yeah, it's interesting that common mode comes down on the outside of the coax, and people don't quite get that. It's almost like a third wire. So number 6 is what we will call the SWR myth. SWR is a good thing. You want to minimize the standing wave ratio, the SWR. But what does it mean if you've got an SWR of 1-to-1 at your transceiver? Does that mean that your antenna has an SWR of 1-to-1? It does not. This is the SWR myth. So in putting up an antenna and attaching coax to it, first check what the SWR is right at the feed point for the antenna. Make sure you've got a good SWR there. Your impedance is right on the mark. It's going to be a good match. Then when you put your coax on there and you run it into the shack and you start testing it, you'll find it'll probably be a little bit different than that perfect SWR match that you had at the antenna. But if it's not high, that's no big deal. You can tune that out, usually even just with the Riggs tuner. But if you think because you got a whopping good tuner in the shack and you can make that antenna 1-to-1, that everything is what my father used to say, copacetic, it might not be copacetic. You may have a terrible match at the antenna. You might not be getting out well. And it never occurred to you that even with a 1-to-1 SWR, you got a problem because you're just measuring it in the shack.
Right. I just had that experience resetting up my mobile antenna. I couldn't put my antenna analyzer on it. I set it for the 440 band. I couldn't do anything, moving the whip up, down, cutting it sideways, whatever. I put the antenna analyzer at the antenna. It was like 1.8 to 1. At the end of the coax, I couldn't get it lower than 2.8, 2.9 to 1. It was all in the coax. I got a new piece of coax, put some new ends on it, boom, right there. So it's very important to actually measure it at the antenna and not the coax, because you may have a faulty piece of coax. Right. And brings us to point number 7 is weatherproofing the connectors. Good grief. You put an antenna up, it's working, your dipole is working great. And maybe a year later, your standing wave is all over the place. You're not getting out. You're getting common mode back in the shack. Okay. You need to weatherproof the connectors, because water, moisture is going to go in there. It's going to attack the solder joints. It's going to attack the shield on the braid. If you're in someplace like Florida or on the Gulf Coast or on the Atlantic Pacific coast, that salt water air gets in there and it simply destroys not the center conductor, but the shield.
Yeah, have you seen it, Tom? Have you seen it, Tom, when you got a problem and you take some of the outside of the coax off, some of the not the shield, but the plastic or whatever type it is. You take a little bit of it off, and then that shield underneath it is all blue and green. Right.
And that's it creates a higher resistance, and you've lost actual physical, mechanical type contact. So with a PL259, the standard for HF, it's not waterproof. You've got to wrap it in self-amalgamating tape or coax seal, or just regular electrical tape isn't accurate. Now they do have an N connector, which is standard for VHF and UHF, and I've actually seen this on like the Mosley antennas. Will have at the antenna an N connector. It's waterproof when it's installed correctly and has much better constant impedance at high frequencies. You want to eliminate water ingress. Water gets inside the braid. The cable is ruined. It'll corrode, turn black, green, blue, any color but copper color.
Yeah.
And the losses will skyrocket.
Yeah. Number 8 is avoid sharp bends in coax. Avoid sharp bends. Now, I should tell you, Tom, on the LMR 400, which I use occasionally, whenever I use LMR 400, I get the kind that's more bendable, because that thick coax, you can so easily get into trouble. You can't quite fit it where you want it coming into the shack or through a hole in the wall or whatever, and you start monkeying around with it and bending it, and then you get into trouble. So avoid sharp bends. Kinking coax is not a good idea.
Well, and along with that, point number 9 is buy quality coax. Avoid the no-name coax from non-radio retailers. You even got to watch it with some regular radio retailers, depending on the quality of cable that they're selling, and it often has poor braid coverage, less than 95%. And that equals high loss. Use quality connectors too. I mean, manufactured connectors can be great, but if you're adding your own connector to a length of coax, get Amphenol. So they're a couple bucks more, but that's a couple bucks less grief you're going to have when the whole thing deteriorates.
Right. Okay, number 10, finally, Tom, is to label all of the coax.
Oh, yeah.
Label it. If you have more than one antenna, put a label on each one coming in so you know which is which. If you are running cables from one piece of equipment to another, maybe multiple pieces of equipment in your shack, put labels on there so that if you are in a situation like I am where it's not easy to get behind the equipment, at least I can look back over behind the piece of equipment and see the label on there saying what it's going to, and then pull the proper piece of equipment out and take the coax out or put new coax in or whatever. Labeling is really, really important. So there you have it, gang. Some things to think about with coax. We hope this is helpful. If you've got additional ideas, go ahead, Tom.
Okay, one thing on labeling everything that I do.
Oh, boy.
And I use either RG59, RG58. I use the thinner coaxes. I take the plastic tags off of bread packages, that hold the twist of seal. They're just the right size. You can write on them with a magic marker and just clip it onto your coax.
Wow.
On both ends. That way, if you're router to your antenna, you want to know which cable is okay. This is cable 1A. I go back into the shack and I look for the other tag 1A. And they're free. You're going to throw it away anyway. Save them. Get a jar full of them.
Brilliant. Yeah, we should get a snoot full of those made cheaply from China and sell them at a ham fest or something, Tom. Make a little do-re-mi on it. You never know. What a great idea. Thanks, Tom. Okay, coax. We love it, but take these tips into account. Post any other ideas you have down below. We'd love to hear from you. This is Ham Radio Perspectives. I'm Quinn, K8QS.
I'm Tom, W89TDD.